Internal combustion engines, heat engines. Thermal prime mover is a prime mover that is made to utilize thermal energy for conversion into mechanical work. Examples: steam engines, steam turbines, gas turbines, diesel engine, and petrol engines. Thermal prime movers are also known as heat engines. A source of heat, a medium to carry the heat, and a converting machine are all required for running the heat engine. The source of heat is a combustion chamber from which heat energy is supplied to the medium. Examples: reciprocating type and rotary type. Reciprocating type consists of a hollow cylinder into which a piston reciprocates by the action of the working fluid. Examples: diesel and petrol engines. Rotary type consists of a wheel fixed upon a shaft and fitted with blades or vanes on it. The wheel rotates due to the action of the working fluid upon the blades. Examples: steam turbine and gas turbines. Internal combustion engines. Heat engines classification. According to the place of combustion of fuel. External combustion. Combustion of fuel takes place outside the engine. Example: steam engines and steam turbines. Internal combustion. Combustion of fuel takes place inside the engine. Working fluid is air fuel mixture. Example: diesel and petrol engines. Internal combustion engines are classified into petrol engine, also called as spark ignition engine, and on the other side as diesel engine, also called as combustion ignition engine. The petrol engine has 4-stroke engine and 2-stroke engine. At the same hand, diesel engine also has 4-stroke engine and 2-stroke engine. Internal combustion engine cut sectional view shows the following parts: cylinder head, combustion chamber, piston rings, cylinder, piston, connecting rod, crank, crankshaft. 4-stroke engine parts diagram. Internal combustion engine parts: engine cylinder, cylinder head, piston, piston rings, piston pin, connecting rod, valves, crank and crankshaft, crankcase, flywheel. Internal combustion engines. Internal combustion engine terminology: cylinder bore, stroke or stroke length, top dead center or inner dead center, bottom dead center or outer dead center, compression ratio, stroke volume or swept volume or displacement volume, clearance volume, air fuel ratio, indicated horsepower, brake horsepower, friction horsepower, thermal efficiency, mechanical efficiency, brake thermal efficiency, volumetric efficiency. Internal combustion engines. 4-stroke cycle engines. Cycle of operation. There are distinctly 4 strokes: suction stroke, compression stroke, expansion stroke, exhaust stroke. For different operations in a cycle, each stroke is identified as per the function. Classification of internal combustion engines: 4-stroke and 2-stroke. 4-stroke cycle engine. In the 4-stroke engine, there is one power stroke in every 4 strokes or during 2 revolutions of the crank. 4-stroke engines are further classified as 4-stroke petrol, 4-stroke diesel. Internal combustion engines, suction stroke. During suction stroke, the inlet valve opens and air and fuel mixture is sucked into the cylinder. The piston moves downward from top dead center till it reaches bottom dead center. During suction stroke, the exhaust valve is closed. Compression stroke. During this stroke, both the inlet and exhaust valves are closed. The air fuel mixture is compressed as the piston moves upwards from BDC to TDC. The compression ratio in petrol engines varies from 7 to 10. As a result of compression, pressure and temperature of the charge are increased to 15 to 20 bar and 400 degree. Shortly before the piston reaches TDC, the charge is ignited by means of a spark plug. It suddenly increases the pressure and temperature of the products of combustion, but the volume remaining constant, temperature 2000 degrees Celsius. Four-stroke cycle petrol engine diagrams. The first diagram shows the suction stroke. The second one shows the compression stroke. The third one shows the working stroke, and the last one shows the exhaust stroke. Internal combustion engines. Four-stroke petrol engine. Petrol engine is also known as spark ignition engine. Four-stroke petrol engine requires four strokes of the piston to complete one cycle of operation in the engine cylinder. It consists of a cylinder. Its one end is fitted with a cover and the other end left open. The cover is provided with inlet and exhaust apertures. These apertures are opened and closed by inlet and exhaust valves. A spark plug initiates the ignition of the fuel. The piston reciprocates inside the cylinder. The connecting rod and crank convert the reciprocating motion into rotary motion. Internal combustion engines. Expansion stroke or power stroke or working stroke. During this stroke, both the inlet and exhaust valves remain closed. Due to the rise in pressure, piston is pushed down with a great force. The hot burnt gases expand, pushing the piston from TDC to BDC. At or near the end of the stroke, the exhaust valve opened to release the burnt gases to the atmosphere. This drop in pressure at constant volume is theoretically represented by the vertical line 5-2. Internal combustion engines exhaust stroke. During this stroke, the exhaust valve opens as piston moves from BDC to TDC. This movement of the piston pushes out the exhaust gases from the cylinder. The exhaust gases are exhausted through the exhaust valve into the atmosphere. The exhaust stroke is theoretically represented by the horizontal line 2 to 1 in the PV diagram. Internal combustion engines. Power cycle of petrol engine. Otto cycle. The petrol engine works on the principle of Otto cycle, also known as constant volume cycle. Suction stroke, compression stroke, power stroke or expansion or working stroke. Exhaust stroke. Uses. Four-stroke petrol engines have higher load carrying capacities than two-stroke petrol engines. Hence, they are used in high power, high speed motorcycles and passenger cars. Internal combustion engines. Four-stroke diesel engine. Instead of spark plug, a fuel injector is mounted in its place. A fuel pump supplies diesel to the injector at higher pressure. It is also known as compression ignition engine since ignition takes place due to high temperature produced during the compression of air in engine cylinder. Liquid fuel, that is diesel, which cannot be vaporized, is injected into the cylinder in the form of fine spray using fuel pump and injector. Power cycle of diesel engine. Diesel cycle. Diesel engine works on the principle of theoretical diesel cycle, also known as constant pressure head addition cycle. Internal combustion engines. Four-stroke cycle diesel engine diagram. Internal combustion engines. Suction stroke. During suction stroke, inlet valve opens and exhaust valve remains closed. The piston travels downwards from TDC. Air is drawn in from outside to fill the cylinder through the inlet valve till the piston reaches BDC. The air taken in is at atmospheric pressure, line AB. Compression stroke. At the end of the suction stroke, both the inlet and exhaust valves remain closed. The piston moves upwards from BDC to TDC. The air sucked in during suction stroke is compressed to a high pressure 35 to 40 bar and temperature with a decrease in volume. These two strokes, namely suction stroke and compression stroke, complete one revolution of the crankshaft. Internal combustion engines. Expansion or power or working stroke. Just before the beginning of the stroke, diesel is injected in the form of fine spray into the cylinder through the fuel injector. At this moment, the fuel is ignited by the temperature of the hot compressed air and it starts burning at constant pressure. Due to the high compression ratio of 16 to 20, the temperature at the end of compression stroke is more than 550 degree. This temperature is sufficient to ignite the fuel injected into the combustion chamber. The fuel is continuously injected for 20% of the expansion stroke. The ignited air-fuel mixture expands and forces the piston downwards from TDC to BDC. During this constant pressure expansion stroke, both the valves remain closed. The piston is forced further during remaining part of the expansion stroke due to the expansion of the burnt gases. Internal combustion engines. Expansion or power or working stroke. The linear motion of the piston causes the piston to produce the mechanical work during this stroke. As the piston moves, the pressure of the hot gases gradually decreases. The expansion of the burnt gases is theoretically represented by the curve dE. At the end of the outstroke, the exhaust valve opens, some of the burnt gases escape into the atmosphere from the cylinder through the exhaust outlet at constant volumes EB. Internal combustion engines. Exhaust stroke. Inlet valve is closed and the exhaust valve is opened, BDC to TDC, so that the piston forces the burnt gases out of the cylinder through the exhaust valve. The exhaust stroke is theoretically represented by the horizontal line BA. Expansion and exhaust stroke complete one revolution of the crankshaft. This completes the cycle and the engine cylinder is ready to suck the fresh air once again. Uses. They are used in heavy duty transport vehicles such as trucks, tractors, bulldozers, etc. Power generation, industrial and marine applications. Internal combustion engines. Two-stroke petrol engine. A specific shape is given to the piston called deflector. The deflector helps to prevent the loss of incoming charge and helps for exhausting the hot gases effectively. It will be easier to describe the cycle beginning at the point when the piston reaches TDC at the end of the compression stroke. In the two-stroke petrol engine, the draw of petrol air mixture into the cylinder will not take place in a separate stroke. Therefore, the method of draw of petrol air mixture should be understood properly. Scavenging. In the two-stroke petrol engine, the exhaust gases are removed from the cylinder with the help of fresh compressed charge. This process of removing exhaust gases is called scavenging. This page shows the downward movement of the piston and the upward movement of the piston. This page shows the two-stroke cycle petrol engines diagram. Internal combustion engines. Two-stroke petrol engine. First stroke. The spark is produced by the spark plug as the piston reaches TDC. The pressure and temperature of the gases are increased and hence the gases push the piston towards producing the power stroke. When the piston opens the exhaust port during downward stroke, burnt gases leave the cylinder through the exhaust port. A little later, the piston uncovers the transfer port and the crankcase is directly connected to the cylinder through the transfer port. The downward stroke of the piston compresses the charge in the crankcase by the underside of the piston. Internal combustion engines. Two-stroke petrol engine. Second stroke. As the piston moves upwards, it covers the transfer port. Hence, a flow of charge into the cylinder is stopped. The upward motion of the piston lowers the pressure in the crankcase below atmosphere and fresh air is induced in the crankcase through the inlet port as it is uncovered. A little later, the piston covers the exhaust port and actual compression of the charge starts. The compression is continued until the piston reaches TDC. The ratio of compression ranges from 1:7 to 1:10. The cycle is then completed within two strokes. The two-stroke engine requires only two strokes of the piston to complete one cycle of operation. The crankshaft makes only one revolution to complete the cycle. Power is delivered in every revolution of the crankshaft. Uses. Two-stroke petrol engines are used in mopeds, scooters, motorcycles because they run at high speeds with moderate power outputs. Internal combustion engines. Two-stroke diesel engine. In two-stroke diesel engine, the draw of pure air into the cylinder will not take place in a separate stroke. First stroke. Position of the piston at the end of the compression. Diesel is injected using fuel injector just before completing the compression. It starts burning. The high pressure, high temperature gases push the piston downwards, producing the power stroke. As the piston moves little down, the supply of diesel stops. In this, the piston uncovers the exhaust ports during the downward stroke. Hence, the burnt gases leave the cylinder through the exhaust port. A little later, the piston uncovers the transfer port. Now, the crankcase is directly connected to the cylinder through the transfer port. Air in the crankcase is compressed by underside of the piston and the compressed air is transferred to the cylinder through transfer port. The exhaust gases are pushed out with the help of fresh air until the piston reaches BDC. This page shows the cylinder, deflector piston, exhaust port, inlet port, transfer port and the fuel injector. In this page, the downward movement of the piston and the upward movement of the piston of the two-stroke engine is shown. Internal combustion engines. Two-stroke diesel engine. Second stroke. The piston moves upwards. It first covers the transfer port and stops the flow of air into the cylinder. A little later, the piston covers the exhaust port and actual compression of air starts. The upward movement of the piston lowers the pressure in the crankcase below atmosphere and fresh air is induced in the crankcase through the inlet port as it is uncovered. The compression of air is continued until the piston reaches TDC. The fuel supply starts just before the piston reaches TDC and the cycle is completed.